Chapter 3, Lesson 2, Solving Systems Algebraically. Today we're going to learn how to solve a system of solutions by substitution and elimination. Okay, we've done a lot of this in Algebra 1 before, so let's just kind of refresh. All right, first example. Solve the system by substitution. Okay, to substitute means we're trying to find a variable to solve by itself. So I'm going to take this first one because I already see y is kind of by itself. So let's take that first equation. Let's rewrite it over here. So I got 2x minus y equals 7. So let's subtract 2x to each side. So I'm going to get negative y equals 7 minus 2x. Now, divide by negative 1 on everything. We get y equals negative 7 plus 2x. So we've solved for y. Now let's write the first equation. 4x plus 3y equals 4. So what we're going to do is we're going to substitute that whole variable we came up for y and replace it. So we're going to get 4x plus 3 times negative 7 plus 2x. All we're doing is replacing the y equals 4. So now we're going to distribute. So we're going to get 4x plus 3 times 7 is negative 21. 3 times 2x is plus 6x equals 4. Okay. Everybody see what we did? We just distributed the 3 to the negative 7 and the 2x. So now we're going to sum like terms. So I'm going to get 10x minus 21 equals 4. So we're going to add 4 to each side. Sorry, add 21 to each side. And we're going to get 10x equals to 25. So divide each side by 10, we're going to get x equals 2.5. So once we solve for x, we can plug this back into the equation we already set for y and solve for y. So that would be y equals negative 7 plus 2 times x, which is 2.5, which is going to be negative 7 plus 5. So our y value would be just negative 2. And we can double check our work. So, all right. So our solution set is 2.5 and negative 2. And if we wanted to write it in ordered pairs, if it asks us to, we'd write our x value, comma, our y value. So our solution set is 2.5, negative 2. Okay. Next example. Solve using substitution. Sorry as this jumps around a little bit. Again, let's use this equation at the bottom, and let's solve for x. So I get x plus y equals negative 12. So subtract y at each side, I'm going to get x equals negative 12 minus y. Okay, so there's my equation for x. Now we're going to take a little space over here to the right, and we're going to plug in our other equation, 2x minus 3y equals 6. So now we're going to plug in the equation of negative 12 minus y for x. So we're going to get 2 times negative 12 minus y minus 3y equals 6. So we're going to distribute the 2. So we're going to get negative 24. 2 times negative 12 is negative 24. 2 times negative 2 is negative 2y minus 3y equals 6. We're going to sum like terms, so I get negative 24. We got negative 2y and negative 3y. So negative 24 minus 5y equals 6. solve for y. Let's add 24 to each side. Okay, so I get negative 5y equals 30. Divide each side by negative 5. Y is now going to equal negative 6. So, we just got to take that and plug it in to this equation. So I'm going to get x equals negative 12 minus negative 6. See, I put the parentheses around the y value because it was negative. So now x is going to be negative 12. Negative times a negative is positive, so plus 6. So x is going to equal negative 6. So my solution set is negative 6 for my x value and negative 6 for my y value. So the answer is D. Okay. 1B, solve by substitution. Okay. Let's look at the first equation. Let's solve for that. So I get 3x minus y equals 0. So let's just flip y. So 3x is going to equal to y. So that was a pretty easy one to do for us. So let's go to the next equation over. 4x plus 3y equals 26. So we're just going to substitute the 3x for y. So it's going to be rewritten as 4x plus 3 times 3x equals 26. So 4x plus 9x, 3 times 3 is 9, equals 26. 4x plus 9x is 13x, equals 26. Divide each side by 2, x equals 2. Alright, so plug that in. So when x equals 2, that'd be 3 times 2 equals y. Y equals 6. So my ordered pair is an x comma y, so my ordered pair is 2 comma 6. Okay. Now let's look. Refer to the chart at the left. The cost of membership in a health club includes a monthly charge and a one-time initial fee. Find the monthly charge and the initial fee. So here's what we know. For 2 months, I pay $200, and for 6 months, I pay $200. So here's what I know. I know I have an initiation fee. We'll make that I. So make that F, I guess. And M is my monthly fee. So for 2 months, I pay $100. So I have 2 times my monthly fee plus my initiation fee equals 100. And I have another example of 6 months. So 6 times my monthly charge plus my initiation fee equals 200. Can we figure out what our monthly fee is and our initiation fee is? Okay. So let's look. Let's take the first equation and let's solve it in terms of f, okay? So I have 2m plus f equals 100. So f really equals 100 minus 2m. So there's my f value, 100 minus 2m. I can just replace it there. So let's take the second equation. Rewrite it 6m plus, instead of f, we're going to insert 100 minus 2m equals 200. Okay, that's our f value right there. So sum like terms, so 6m minus 2m is going to be 4m plus 100 equals 200. We're going to subtract 100 to each side. So we get 4 m equals 100. Divide each side by 4, so m is going to equal 25. So m equals 25, we can plug this in right here. So f equals 100 minus 2 times our monthly fee, which is 25. So our initiation fee is 100 minus 50. So our initiation fee was $50. So our initiation fee is $50. Our monthly fee is 25. Okay. Next example. You can buy you can buy CDs at a local store for $15.49 each. You can buy them online for $13.99 each plus $6 shipping. Solve a system of equations to find the number of CDs you can buy for the same amount at the store. Okay. So I know at the store, every time I buy a CD, it's going to cost me $15.49. Okay. For every CD I buy online, it's going to cost me $13.99 plus a $6 shipping fee regardless how many I buy. So we can set an equation equal to each other. So we can say 15.49x, that's what we could buy at the store, is equal to 13.99x plus 6. So now we're just going to solve for x. So step 1, we're going to subtract $13.99 from each one of these. So when we do that, we're going to get 1.5x equals 6. Divide each side by 1.5. So x is going to be equal to 4. So if I buy 4 CDs at the store or 4 CDs online, it costs me the exact same. All right, now substitution by elimination. This way is a little bit easier if things work out for us. So 4x minus 2y equals 7, and I have x plus 2y equals 3. All right, when I add equalities, meaning the two equal signs here, I can add them and it's going to always be true. So when we add these as they are, what do you notice? Well, the y's are going to cancel, so it's going to be 5x is equal to 10 because negative 2y plus 2y is 0. So now I got an easy equation, 5x is equal to 10, so I eliminated one of my equations, or one of my variables. So solve for x. Divide each side by 5, x equals 2. Now, it does not matter which equation I plug this into. It's going to work out either way. So let's use the bottom equation. So I got x plus 2y equals 3. Well, I have an x equals 2. So 2 plus 2y equals 3. I'm going to subtract 2 to each side. I'm going to get 2y equals 1. Divide each side by 2. Y equals 1/2. Okay, and you can plug that into either equation. You're going to find out it works. So, again, you'd write your solution set as 2, 1/2. Okay. Here we go. Another additive inverse. Solve 3x minus 2y equals 14, 2x plus 2y equals 6. So I got 3x minus 2y equals 14, and I got 2x plus 2y equals 6. Okay, since they're equalities, we can just add them up. So I get 5x equals 20. See how the y's cancel? Divide each side by 5. I'm going to get x is equal to 4. Okay. So now we just plug it into the next equation and solve for y. So we're going to get 2x plus 2y equals 6. Plug in x equals 4, so you're going to get 2 times 4 plus 2y equals 6. So that's 8 plus 2y equals 6. Subtract 8 to each side. So we're going to get 2y equals negative 2 or y equals negative 1. We can plug that in and see. So our ordered set would be x comma y, which would be 4 comma negative 1. So the answer would be B. Next example. Solve 4x plus 9y equals 1 and 4x plus 6y equals negative 2. Okay, so since we have the same term, let's just change the signs of one of them. So we'll make that a negative 4, a negative 6y, so negative 4x, negative 6y, and a positive 2. Now we can just add all this together. So 4x plus negative 4x is going to be 0. 9y minus 6y was going to be positive 3y. And 1 plus 2 is going to be 3. So 3y equals 3. So divide each side by 3. Y is going to equal 1. Alright. Now it does not matter which equation we plug y equals 1 in. Alright. So now we just plug y in. And we could get, let's plug it in the first one. So I get 4x plus 9y equals 1. So we plug in y equals 1. So 4x plus 9 times 1 equals 1. So 4x plus 9 equals 1. Subtract 9 to each side. We're going to get 4x equals negative 8. Divide each side by 4. We're going to get x equals negative 2. So our solution set is negative x, or sorry, x comma y. So x comma y. So it would be negative 2 comma 1. We can always go back and check our work if we need to. Okay? So here we go, solving an equivalent system. Solve the system below by elimination. So I have 3x plus 7y equals 15 and 5x plus 2y equals negative 4. Okay, so we need to find something common that we can use. Alright, so I believe if we multiply the top system by 5 across the board and the bottom system by 3 across the board, we can come up with an x we can eliminate. So let's do that. So I have 3x plus 7y equals 15. So I can do whatever I want to any equation as long as I multiply everything by the same. So we're going to multiply each side of this equation by 5. And what are we going to get? Let's find out. 5 times 3x is 15x plus 5 times 7y is 35y equals 5 times 15 is 75. So there's that equation. So let's take the second equation. 5x plus 2y, we're going to multiply that by 3 as well, equals negative 4, and we're going to multiply that by 3. And again, we chose 5 and 3 just because it was the least common denominator that we could use. So 3 times 5x is 15x. 3 times 2y is 6y. So I got 15x plus 6y on the left equals negative 4 times 3 is negative 12. So we compare these up real quick. So I'm going to rewrite this equation here. So 15x plus 6y equals negative 12. Change the signs on the bottom one. So that's going to become a negative 15, a negative 6y, and a plus 12. So when we sum these up for elimination, we're going to get 15s are going to cancel. The 15x's are going to cancel. 35y minus 6y is 29y. Alright. And 75 plus 12 is going to be 87. Okay, divide each side by 29. So So we got 29y equals 87. Divide each side by 29. And we're going to find out y equals 3. Okay, when we solve for y equals 3, we can go back to any of the original equations, either one, and solve. So let's go with the second one. So let's rewrite it. 5x plus 2y equals negative 4. So 5x plus 2 times 3, we're just subbing it in now, equals negative 4. So 5x plus 6 equals negative 4. Subtract 6 to each side. 5x equals negative 10. So x is going to equal negative 2. So my solution set would be negative 2, 3. All right, makes sense? All right, moving on. Solve each system by elimination. Okay, let's look. So we have an example, 2x minus y equals 3 and negative 2x plus y equals negative 3. So what we're going to find out is their inverses. All right, elimination gives us the equation that is always true. The two equations in the system represent the same line. So the system has an infinite number of solutions. All right, so if it's a true statement, once you do elimination, it's always going to be a true statement. All right, now let's look at the second example. 2x minus 3y equals 18, negative 2x plus 3y equals negative 6. Elimination gives us an equation that's always false. The two equations in the system represent parallel lines and hence have no solution. All right, so here we go, solve. (3x plus 5y equals 7) and 6x minus 10y equals negative 14. So let's look at the first equation. 3x plus 5y equals 7. So let's multiply that equation by 2. So what are we going to get? Negative 6x. Again, we're just going to multiply each term by 2. Plus 10y equals 14. All right, what was our second equation? We're going to write it right here. 6x minus 10y equals negative 14. So we're going to get 0 equals 0. So it must be the same line. Okay, so we're going to say the solution set is this. X comma y, infinite many solutions of the equation negative 3x plus 5y equals 7. Okay, so that's how we're going to write our solution set. Going back a couple of slides, we can look at that. Elimination gives us an equation that's always true. This true equations in the system represent the same line. It has infinite number of solutions, so we're just going to write it as x comma y and then write the equation over. Okay, does everybody see what we did? Okay. Next equation. Negative 2x plus 4y equals 6. Negative 3x plus 6y equals 8. So let's look to see what we can multiply these by to make it a little bit simpler. Okay, let's zoom in. Let's multiply the top equation every term by 3, and let's multiply the bottom equation every term by 2. Let's see if we can speed this up a little bit. 3 times negative 2x is negative 6x. 3 times positive 4y is positive 12y. And 3 times 6 is positive 18. So we multiplied that one by 3. Now let's multiply the second one by 2. 2 times negative 3x is negative 6x. 2 times 6y is positive 12y. And 2 times 8 is 16. So if we subtract them, we just got to change our signs on the bottom ones. We'll make that a plus, make that a negative, and make that a negative. So we're going to get 0 equals 2. Well, that's not true. So we have no solution. They are parallel lines. Same slope, different y-intercepts. Okay, I hope that made sense for you. Review it if you have any questions.